Now let's take a look at negative exponents. We've technically been looking at negative exponents when we did the division problems, but we didn't actually have negatives. So now we're going to throw the negatives in there, but we're really looking at the same ideas as behind the dividing exponents. So when I take, and I've got b to the negative 3, that actually, by definition of negative exponents, what happens is that that negative causes the b to the third to go from the top of the fraction to go to the bottom of the fraction. And the same thing happens when I look here. I've got a b to the negative third in the denominator. So if it's in the denominator and it's negative, it goes to the top of the fraction and becomes positive. The way that I always remembered it is that when you get in trouble and you're supposed to be on the top floor of your house, and you go to the bottom, like in this situation, you're in the wrong place. And so that negative exponent is symbolizing that you're in the wrong place. And so you need to go to the other place. Okay? And so if you're in the basement, you need to go to the top. If you're in the top floor, you need to go to the basement, okay, depending on where your room is. So a negative exponent is going to be an exponent that moves the variable or any base from the numerator to the denominator or vice versa and makes the exponent positive. So you can see a couple examples here. The b to the negative third, it needs to go from the top here to the bottom here. The b to the negative fifth needs to go from the bottom here to the top here. And they ended up switching places. But then we follow the same rules that we had before. I've got 5 b's on top, and I've got 3 b's on the bottom. So these 3 b's are going to cancel out with those 3 b's, and I end up with b to the second on top. There's 2 b's left on top. And notice that the c to the fourth and the c to the sixth, nothing is wrong with those. Nothing says that they need to move to different places. So they don't have negative exponents, they have positive exponents. And so if I'm looking at simplifying the c's, I've got 6 c's on the bottom and 4 c's on top. The 4 c's on top are going to cancel with 4 c's on the bottom, leaving just 2 c's down here, and I end up with b squared over c squared. The next example, I've got a negative 2 with a to the negative third. This is the exponent part that needs to move. It needs to move from the top to the bottom. The 8 stays in the same place. The 8 to the fourth stays in the same place. The negative 2 stays in the same place. It is not a negative 2 with any negative exponent, so it needs to stay there. Now I just reduce the fraction. 2 goes into 2 once, and 2 goes into 8 4 times, so I get negative 1 on top, a 4 on the bottom, and then I've got 3 a's here and 4 a's here, so I've actually got 7 a's in that denominator. And if we just move down a little bit here, we want to look at the next example. I've got a to the negative third. This is the part that has the negative exponent. That has to move to the denominator. It was in the numerator because I can put this over 1, so it needs to move to the denominator. When it moves to the denominator, it becomes a positive exponent. Notice that the negative 4 did not move. The negative 4 is not attached with that exponent. It does not have that exponent. It has an exponent of a lazy 1. So negative 4 to the first needs to stay on top. It has a positive exponent. On the next example, though, when I put all of that in parentheses, then all of this is attached with that negative exponent. It needs to go down here to the denominator and become positive. And when it vacates the top and there's nothing else left on top, then it leaves a 1 there, because technically there's a lazy 1 out in front here, 1 times that, and so that 1 gets left there because it doesn't have the negative exponent. And then we can do 2 to the third is 8, and then a to the third is a to the third to get the final answer that we had here. And then the final example, a to the fifth is the negative exponent, needs to move to the numerator. The 4 is not attached to that negative 5, so it needs to stay in the denominator. And the 1 that was on top technically is still there. It's just in front of the a to the fifth. And then the last thing to remember is that anything to the 0 power is equal to 1. So if I take a number, in this case this is a 5. 5 to the 0 power, that's a 1. N to the 0 power, that's a 1. If I take something in parentheses to the 0 power, that's also a 1. This was the last rule that, that we were looking at in terms of these exponents. And where that comes from is if I take 5 squared, or even 5 cubed, that's 125, which is 5 times 5 times 5. And 5 squared is 25, which is 5 times 5. And 5 to the first power is 5, which is just 5. As you can see, what ends up happening here is that I'm really just dividing out one of these 5s each time. So when I go to 5 to the 0 power, I end up with no 5s left, which means that I divided this 5 by 1, and I end up with just a 1. So then that gets us into the negative exponents, because let's see what happens when I get a 5 to the negative 1. If I took that 1 and I divided it by 5, I get 1/5. And then if I go 5 to the negative second, that's 1 over 5 to the second. We just talked about that rule. And that's 1 over 5 times 5. This one's 1 over 5. I'm just dividing by 5. And so I started off with 3 5s, 5 to the third, divided by 1 to get 5 to the second, divided by 1 5 to get 5 to the second, divided by 1 5 to get 5 to the first, divided by 1 5 to get 1, divided by another 5 to get 1/5. And no matter what the numbers are, this continues to be the case. If I put a 3 there, 3 cubed is going to give us 27. 3 squared is 9. I divided by 3. 3 to the first power is 3. I divided by 3. 3 to the 0 power is 1, because 3 divided by 3 is 1 again. 3 to the negative first power is 1/3, and so on. So the rule holds true for anything that is to the 0 power to be equal to 1. Now let's just quickly look at a couple examples from the back page here. My number 1 didn't really show up, but this is number 1. So again, the thing that is attached here to the negative exponent is the a to the negative third. So I've got a 5 that still stays there on top, and the a to the negative third goes down to the bottom. And that's all I have. There's nothing more to that. As opposed to number 2 here, which the 3a, that whole thing is raised to the negative 4th power. So that whole thing has to go down to the bottom and raised to the positive 4th power, which then is 1 over 3 to the 4th and a to the 4th. 3 to the 4th is 81, so this is 1 over 81 a to the 4th. Just quickly looking at number 9, I've got 1 over 5 to the 0 power. We just talked about that. Anything to the 0 power is 1, and so I end up with 1 over 1. This continues to be an issue as we continue in the rest of these problems, and as they continue to add with all the rest of the exponent rules that we had. So let's take, let's say, a quick look here. This is going to be number 7, I believe, down here in the bottom left corner. The first thing when I look at these problems, the first thing that I see is I see that negative exponent. So I want to get rid of those negative exponents. This needs to go down to the bottom, and this needs to come up to the top. So I have 14, a to the 5th, b to the 2nd, over 21, a to the 3rd, b to the 6th. So the first thing that I want to do is get rid of the negative exponents, and I want to do this whole problem in steps. So now I've got 14 over 21. I can reduce that. 7 goes into 14 twice and into 21 3 times. So I end up with 2/3 for the numbers. I've got 5 a's on top. So again, the long version of this, which you don't need to do, and 3 a's on the bottom. The 3 a's on the bottom are going to cancel with 2 on the top, or 3 on the top, leaving me with 2. And then the same thing with the b's. There's 6 b's on the bottom and 2 b's on top. These 2 on top are going to cancel with 2 of them on the bottom and leave me with 4 of them left on the bottom. And so I end up with 2/3 and then a squared b to the 4th on top of this fraction. And then one more, the number 14. I've got 25, that's fine, no negative exponent. M squared, no negative exponent. The 30 has no negative exponent, and the n to the 5th has no negative exponent. The things that have negative exponents are n to the negative third, so I need to bring that down. And the m to the negative fourth, so I need to bring that up. And my negative exponents are gone. I can reduce the numbers, 25, so 5 goes into 25 5 times, and into 36 times, so I end up with 5, 6. The m's on top, there are no m's on the bottom, so I'm just doing the m's on top. I've got 2 m's and 4 m's using the exponent rule where I add those together. But again, if you understand what the long version is, there's 2 m's and 4 more m's. I've actually got m to the 6th. And then on the bottom, the same thing, 3 n's and 5 more n's gives me n to the 8th down in the bottom. And so be careful with those negative exponents. Do these problems each in steps. Don't try to rush through them without rewriting what you need to rewrite.